Good afternoon, all of you. In today's session of class 11 physics, we will discuss the question given in the homework last day. Okay, so this was the question given in the homework of last session. S is equal to t square plus t. So if you compare it with half a t square plus ut, then half a will be 1 and u will be 1. So acceleration is 2 and initial velocity is 1. Now the thing is that so the velocity, you know that the formula is u plus at, so it will be 2t plus 1, and acceleration is 2, so it is uniform acceleration. So these are the displacement time, velocity time, acceleration time graphs for the homework question which was given last week. And in this homework you can see one thing very clearly, that if you calculate the area under the velocity time graph, so this is the trapezium. So if you calculate the area of the trapezium, it is coming to 4 meter. So between 1 second and 2 seconds, the displacement is 6 minus 2, that is 4 meter. And if you calculate the area of this, so 2 into 2 minus 1. So that means the change in velocity is 2. So if you do 5 minus 3, you will get 2. So area under velocity time graph gives the displacement, and area under acceleration time graph gives the change in velocity. And the other thing is that the slope of the velocity time graph is 5 minus 3 by 2 minus 1. So that is the uniform acceleration 2 meters per second square, right? So the slope of velocity time graph is giving the uniform acceleration. Now there is a problem that how can you find slope of displacement time graph? So you cannot find, because it's a curve. So then how do we find it? Like if we want to know the slope of displacement time graph, then how do we know it? And by the way, you know slope is change in displacement by change in time. So slope of displacement time graph is velocity, and the velocity we have already got 2t plus 1. But can you get it by any other method, or is it that you have to compare it with equations of motion? So the answer is that there is another method. What is that? So like I said, change in displacement by change in time is average velocity. So if you make the displacement and the time negligibly small, suppose the displacement becomes negligibly small ds and time becomes negligibly small dt, then this is called the instantaneous velocity. Now the problem is that the calculation of this ds by dt has to be done by some formulas of maths, and that entire thing is called calculus. So for the time being, just remember this, that if s is t to the power n, then ds by dt is n into t to the power n minus 1. right? If s is t to the power n, ds by dt is n into t to the power n minus 1. And if suppose you say that s is a constant, so constant can also be let us say that s is a constant into some other variable z, so then ds by dt will be constant into dz by dt. So if s is equal to constant into z, ds by dt will be constant into dz by dt. So the constant will just be there, it will not participate. And another thing is that if there is any plus or a minus sign, it will stay there. So this is the calculation. You will have to say that ds by dt is d by dt of t square plus t. So that is d by dt of t square plus d by dt of t. Now d by dt of t square is 2 into t to the power 2 minus 1, and d by dt of 1 is 1 into t to the power 1 minus 1. So ultimately the velocity ds by dt is coming to 2t plus 1. So this technique of calculating instantaneous velocity by using ds by dt, this technique is called differential calculus. And now based on this, I am giving you one homework question, that if s is 3t square minus 18t, then find the instantaneous velocity and find the instantaneous acceleration. This is your homework, right? So using this newly learned technique of calculus, you will have to find, if s is 3t square minus 18t, you have to find the instantaneous velocity and the instantaneous acceleration. So that's it for this session, and on that note I'll end the session. Bye all of you.